Hi, welcome to Unit 6, Day 7, two-step mole conversion problems. This is an introductory video that will help support you in the examples and the practice problems that you'll be doing later. So before we begin in learning about one-step mole conversion problems, let's recap, two-step mole conversion problems. Let's recap one-step mole conversion problems, which we've done the last couple of lessons. So an example of a one-step mole conversion problem would be this one here. How much does 1.20 moles of NH3 weigh? So in order to tackle a problem like this, we're trying to figure out how much that amount of NH3 weighs. We need to convert from the moles to the mass. And the first thing we do is choose our conversion factor. So we know we're trying to go from moles to mass. We map out our plan. We're going from moles to mass. And to choose the conversion factor, we can use our mole map. So we're starting with moles, and I'm going to put a blue star where moles is on the map. And we're trying to get to the mass. So I'm going to put a pink star where mass is on the map. Now, in order to go from moles to mass, I have to pass through the 1 mole equals molar mass conversion factor. So that's the conversion factor I'm going to use for this problem. So now that I've chosen the conversion factor, I can move on to step 2, which is using dimensional analysis to solve. So in using dimensional analysis to solve, I start by writing my given over 1. And in this case, I'm given 1.20 moles of NH3. So I put it over 1 just to make it into a fraction. Then the second thing I'm going to do is I'm going to multiply that by the fraction that I get from my conversion factor. So my conversion factor is 1 mole equal to the molar mass of NH3, which is 17.04 grams. And by the way, I just got this from using the periodic table. Now, since I want to find the mass, I want the units I want to keep in the end to be in grams. So that means I want to get rid of moles, right? I want to get rid of the moles that are here. So in my conversion factor, I'm going to put the 1 mole on the bottom and then the 17.04 gram on top so that the moles can cancel out. Remember, when you're multiplying fractions, in order for things to cancel out, they have to be in opposite positions. Since the moles that I want to cancel out is on the top in the numerator of the first fraction, moles need to be in the denominator of the second fraction. Okay, so now I can just multiply my two fractions together to get my fine 20.4 grams. Okay, the next thing that we are going to look at is another problem like this. And this problem, how many moles of CH3OH contain 4.36 times 10 to the 25 molecules? So once again, my first step is to choose my conversion factor. I map out my plan. I'm starting with the number of molecules, and I'm trying to get to moles. So here, in this case, I'm going to put my blue star, the number of molecules, that's where I'm starting, and I'm trying to get to moles, which are here in the middle. So what conversion factor do I need to pass through to get that? Well, I pass through the Avogadro's number of conversion factor. 1 mole is equal to Avogadro's number, or 6.02 times 10 to the 23. And in this case, it's molecules, since that's the units that I'm using. So now that I've chosen my conversion factor, I can now use dimensional analysis to solve. I start by writing my given over 1. So the 4.36 times 10 to the 25 over 1. Just remember, I'm putting it over 1 just to make it into a fraction. And then in the second fraction is going to come from my conversion factor. Since I want to get rid of units of molecules, I put the 6.02 times 10 to the 23 on the bottom, so so molecules can cancel out, because they have to be opposite to cancel out. And then 1 mole goes on top. And then I get my value there of 72.4 moles. Okay, so that's how we did it for one step. Well, what about for 2 steps? So first of all, let's look at an example problem. How many atoms are there in 2.3 grams of neon? Okay, so the steps are pretty much the same. We're going to choose our conversion factors. So I'm trying to go from mass to number of atoms. All right, cool. So if I'm starting at mass, and I'm trying to go to number of atoms. All right, so starting with mass, I had to change the color of the stars there, sorry, mass, and I'm trying to get to atoms. Now, notice that there is no direct line that goes directly from mass to atoms, right? I can't do that here. I can't do that on this mole map because there's no road connecting them. There's no conversion factor connecting them directly. So what conversion factor am I going to use? Well, in this case, since there's no direct conversion factor to go from mass to number of atoms, I'm going to actually have to use two conversion factors. Because what I'm going to have to do in this case is go from mass to the moles, and then from moles to the number of atoms. Okay? So that's the reason why these problems are called two-step conversions, because I'm actually having to go through two conversion factors. I'm taking two roads to get from my given to my find. So what exactly does that look like here in terms of the math and solving the problem? So the first step, as I said, the steps are the same from one step to two step, except for I'm just using two conversion factors. So in this case, my plan is to go from mass to moles to number of atoms. And then the conversion factors that I use to do that, well, let's take a look. If I want to go from mass to moles, the conversion factor I would need is 1 mole is equal to the molar mass. And if I want to go then from moles to number of atoms, the conversion factor that I would use is 1 mole is equal to Avogadro's number. Okay, so these are the two conversion factors that I use. Now I can go ahead and use dimensional analysis to solve. So for my dimensional analysis, I would do given over 1. Remember, we put it over 1 just to make it into a fraction. There's no units there for that 1 because it's just to make it into a fraction. Then I'm going to multiply it by this first conversion factor set up as a fraction. And I'm going to put the 1 mole on top because what I'm trying to do is end with, I'm trying to convert this to moles at this moment. And I want to cancel out the units of the given, so they have to be opposite. Then I'm going to multiply it by the second conversion factor fraction, which is going to come from, in this example, 1 mole is equal to Avogadro's number. So it would be conversion factor of what's given here over the 1 mole. That way the moles will cancel out. And then I get my find in the end. So what exactly does that look like for this problem? Okay. So we're going to start with 2.3 grams over 1. That's my given. Multiplied by 1 mole over 20.18 grams. That's the molar mass of neon. So that way grams will cancel out. And then multiply that by 6.02 times 10 to the 23 over 1 mole, so that the moles will cancel out, and leaving me with 6.86 times 10 to the 22 atoms. Okay, so that's how we get our answer here. And I just want to point out one correction that I made. This should be CF of the find, not the CF of the given in that second conversion factor. So whatever you're trying to find, that unit should be on top here so that you can end with units of your find. Okay, so what I want you to do now is I have the work shown for both 1-step and 2-step mole conversion factors. And I want you to do is I want you to compare things that you notice that are similar and different between the two. Because remember, one important strategy for learning and understanding things is compare and contrast. So what's similar between a 1-step and 2-step, and what's different? Pause the video now. When you press play again, we'll discuss. Okay, so let's take a look at things that you only find. I'm going to use this Venn diagram sort of to things that you only see in a 1-step and only see in a 2-step. So in 1-step conversion factors, you use only one conversion factor. But in 2 steps, you use 2 conversion factor. And that's where the name sort of comes from, how many conversion factors you use. In a 1-step problem, your given or your find will be in moles. Okay, so either your given is in moles or you're trying to find something in moles. In a 2-step, neither the given nor the find will be in moles. You could go, so in a 2-step problem, you can go from mass to volume, or from volume to number of atoms, or from number of atoms to mass. But notice that you don't have moles in your given or find. Whereas in a 1-step, you can go from moles to mass, or volume to moles, or from number of atoms to moles, right? There's moles there in the problem. And then finally, in terms of the math, the things that you see in a 1-step, you multiply 2 fractions together, but in a 2-step, you're going to multiply 3 fractions together. So in a 1-step, you're multiplying your given and your conversion factor fraction. In a 2-step, you're multiplying your given and 2 conversion factor fractions. So now that we look at the differences, what about similarities? Well, things that you will find in both is that the steps are the same. You're always going to start by choosing the correct conversion factor. That's the first thing you need to do. After you read the problem, identify your given and your find, you're going to use your mole map or your understanding of the 3 conversion factors you need to know to pick the right ones. After that, you're going to use dimensional analysis to solve. And the concept of dimensional analysis has not changed. You're always trying to cancel out the units you don't want by putting them opposite to one another and keep the units you do want. Okay, last CFU. So for this CFU, you're going to read each problem and see if you can identify if it is a 1-step or a 2-step. And then once you've done that, I want you to map out a plan to solve. So for this, you may need to have a mole map or some other sort of notes to sort of help you. All right, so go ahead and pause the video now. When you press play again, the answer will be revealed. Okay, so let's go through these answers. The first question or problem asks, how many molecules of O2 are there in 2.5 liter tank of O2 at STP? So notice that we're going from the volume to number of molecules. And our given and our find, neither of them are in moles, so that's our clue that this is a 2-step mole conversion. So in terms of plans, we would go from what we're starting with, our volume, to the moles, and then from there to the number of molecules. Remember, for these 2-step problems, you're always going to have moles in the middle of your plan. All right, next question. How many moles of O2 are there in a 2.5 liter tank of O2 at STP? Well, in this example, it's a 1-step problem. And I know it's a 1-step because my find in this case is in moles. So if your given or your find is in moles, you know it's a 1-step problem. And then, so in terms of plan, I would start with my volume and then go straight to moles. Next question, how many grams are in 8.2 times 10 to the 22 molecules of N2I6? Well, in this example, it's a 2-step because neither the given nor the find are in moles. So we're given number of molecules and we're trying to go to grams. For our plan, we would go from number of molecules to moles and then from there to mass. So remember, for 2-step problems, you always have to go through moles. Last one, how much does 4 moles of helium gas weigh? So in this case, we're given moles. So since we're given moles, we know it's a 1-step. Remember, if you're given or asked to find moles, you know it's a 1-step conversion. And then our conversion will go from moles to the mass. All right, so what are we going to do next? There are some there's an example and practice problem worksheet. You're going to watch the example videos and follow along. After you've done that, you're going to complete the 2-step mole conversion practice. Check and correct your answers, and then you're going to complete some mixed practice that has both 1-step and 2-step mole conversion problems. And then you'll take your exit ticket. All right, that's it for this video. Have a quality day.